today is a new topic, and first subheading is the length of an interval. A line is usually drawn with arrows at both ends to show that it runs infinitely in both directions. So it's going forever to each side, okay? However, an interval or line segment is part of a line with endpoints on both sides and a definite length. The interval joining points P and Q is called the interval PQ, shown in the green in example 1 below. Well, we will have a look at the example in a minute, but I did draw something different right here. We can calculate the length of an interval or the distance between 2 points on a number plane if we know the coordinates of its endpoints. Now, coordinates is the x value and y value in the point form. So, for example, like 2, 3. These are the coordinates of endpoints. So, you should have a 2 points, wouldn't you? Because it's at both ends. Here is a line. Now, can you see the difference here? This is an interval on my right, and on my left is my line. So it has the arrows indicating it's keep going, but in an interval, it stops. In this case, it stops at -2 and then stops at 1. Okay, so that's the interval, the distance in between two endpoints. Now, this can be done with a number plane. What I've just done is number line, directed number line. But if I do it on a number plane, it will look like this. So point A is 1 and 1. So for example, here, that's 1, that's 1. And the point B, that's 5, that's 3. As you can see, this interval has 2 points, endpoints. One is 1 and 1, the other one is 5 and 3. That's what it means by coordinates of endpoints. Example 1. Find the distance between the points. So we're looking for a distance of interval. Point P and point Q. It is a good idea to plot them on the number plane first. So for example, first one, we got P is -4 and -2. First one is x coordinate. Second one is a y coordinate. It starts from x-axis. So I'm going to go with P -4 here, right there, -4 and -2. So go down by 2. It's right there. P is right here, -4 and -2. And 2 and 6, I'll start with a 2 and going up by 6 right there. That's my Q. All right, and then we join them together, then you can see the distance, isn't it? You can see interval, and D is the interval length, the distance. That's what we're looking for. Now, how do we find this? I mean, you might say, oh, can't we just use ruler and measure it? That's not a bad idea, but what if it's not in scale? It's not, what if it's like kilometers and you can't really use ruler? Doesn't really matter what units you have. If we have 2 points on a number line, we can use Pythagoras to find D, which is the interval. So can you see the right angle triangle here on this number plane? The D interval distance is hypotenuse, isn't it? So I'm just going to draw right angle triangle here, and that's the D, P, and that's Q here. I need to find the distance, okay, that's my T here. I need to find this distance and this distance. When you look at the number plane, I'm doing distance of PT right now. So I'm going to count each space. 1, 2, 3, 4, 5, 6. So it's got 6 here. And then a distance of T to Q. 1, 2, 3, 4, 5, 6, 7, 8. So it's 8 here. And then we have to find D. So what's Pythagoras theorem? It was right angle triangle, and it was a C, A, B. and then find the hypotenuse, which is C. C squared equals A squared plus B squared. And if we wanted the C by itself, with the square root, we put it all in. So in here, to find D, all we need to do is square root, square, and add those two numbers. So it'll be 6 squared plus 8 squared. Put it in your calculator, you will get 10 units. I just said 10 units. Part B is exactly the same. Now, first step will be plotting those 2 points on the number plane and then join those 2 points together to make interval, the line with the 2 endpoints. If I move that triangle out, it'll look like that's my D, that's my B, that's my A. This is the part that I just re-sketched it. What will be my TB on this side? So it'll be 1, 2, 3, 4. So that's my 4 spaces there. And then A to T, I'm just going to put this T there. 1, 2, 3, 4, 5, 6, 7. 7. Okay. And how are we going to find a D? By using Pythagoras Theorem. I'll just use square root and then put the 2 shorter sides and square them and add them. 7 square plus 4 square. Put it all that into your calculator. You will get decimals. 8.06225, and I will just have 8.06 in the 2 decimal places, units. Okay. Example 2. Plot the points. There's 4 points there, A, B, C, D, on a number plane and join them to make a quadrilateral ABCD. Now it is quadrilateral because quadrilateral is the shape with the 4 sides. So you have 4 points. When you join them, you will have 4 sides. So, and then part B says what type of quadrilateral is ABCD? And C says find the exact length of AD. Now exact length of AD, this is the one that we'll have to find interval. So therefore we have to use Pythagoras theorem. And then D, hence find the perimeter of ABCD. If you know all the sides, 4 sides, and add them together, that'll be a perimeter, and correct to 2 decimal places. All right, part A, plot the points. So there are 4 points. Let's have a look. I'm looking at the first one, 0 and 6. You start with a 0, it went up by 6, so it'll be here. 5 and 6, that's B, that's my A. So point B is 5 and 6. So I went to the 5 on my right and went up by 6 right there. That's my B. 5 and 2 for C, still same. And I went up by 2. That's my C. And D is a -4. Okay, we'll start from -4 here. And then went up by 2. That's D. If I join them together, I will have something like this. You need to use a ruler on a grid paper. It's a quadrilateral for sure. Part B. What type of quadrilateral is ABCD? So let's have a look. There are 6 quadrilaterals we've done so far. We know a square, we know rectangle, we know parallelogram, we know rhombus, we know kite, we know trapezium. I don't see this is a square because square has to be all sides equal. And rectangle, rectangle has to have a right angle on each corner, just like a square. But there's 2 right angles, but these ones are not right angles, isn't it? We don't know that's what angle that is, so no. Parallelogram has 2 pair of parallel lines. So I've got 1 pair I can see, but I don't know about this, and this one is parallel. So I can't say this is parallelogram. Rhombus is like a square but tilted. So if it's not square, it can't be rhombus because that's not 4 sides equal. And kite, doesn't look like kite either. So it needs to be trapezium. Okay, part C, find the exact length of AD. Now, when it says exact, guys, that means we're just going to have to leave it as a square root. Don't put it in a decimal. Let's have a look. AD, I've got this, and to find the interval AD, we need to have a right angle triangle, isn't it? So what I'm going to do is I'm going to take this part out because that's my right angle triangle, and I'll just put it in here, right there. I need to know the length of here and the length of here. Look at the bottom part of it. 1, 2, 3, 4. So that's 4 here. And the side one, 1, 2, 3, 4. So 4 and 4. Oh, therefore my D be 4 squared plus 4 squared. You will get, ooh, I can see it. It's 32 because 16 plus 16. Okay, so 32. Now, I'm going to leave it as it is because it says exact length, meaning leave your answer in a square root form. All right, D, hence, that means therefore, find the perimeter of ABCD. We know that this is square root of 32. We just found that. What about the length of AB? 3, 4, 5. Okay, so that's 5. And this one, 1, 2, 3, 4. 4. And this one is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so let's write it all those values here. So AB was 5, BC was 4, CD was 9, AD or DA is 32. You will get 23.656854 ... and it says 2 decimal places, so it's going to be 23.66 because the third decimal value is bigger than 5. It rounded up 1 to the next number, and so to become 5 becomes 6. Okay, so I'm just going to go, perimeter is 23.66 units. So that's my answer. And that's all for today's lesson. Well done, people. Thank you.